Okay, so yeah, we already know, okay, 2s and 2p, right? Okay, and suppose we mentioned there is the sigma 2s and sigma 2s star, no problem, right? Okay, then 2p, for example, is p2. Okay, so suppose there is the sigma 2p, pi 2p, and what? Pi 2p star and sigma 2p star. Okay, but in next semester, no, in the second years, okay, the first semester you will take the mathematic method, 化学数学 chemical mathematic method, and the inorganic chemistry in the third year. Okay, you will learn more about the molecular orbital. But here, there's one thing you need to know. Okay, in the beginning it's like this, but for B2, because this is sigma 2s, right? 2p, right? And it's the same phase as the sigma 2s star, because they are sigma. Okay, so they will have the interaction. And at this moment, when two bonding has the interaction, the higher bonding will bump up, and the lower one will decrease. Okay, so it means it no longer like this one. It will bump up. The 2s is 2p, right? Is pi 2p. So the sigma 2p will bump up. Okay, and 2s sigma 2s star will decrease. Will lower the energy. Okay, interaction between two bonding. Okay, it will make at the beginning the lower energy level will decrease. The higher one will jump up. Okay, so it no longer like in the beginning. This one, the sigma 2p is down, is lower than the pi 2p. Okay, and this kind of interaction we call is orbital mixing. This one may not show in your contact book, but the final exam I will have the question to ask you about the orbital mixing. Okay? If you couldn't answer it, I think you will fail your final. Okay? Okay? Orbital, molecular orbital. Okay, the final exam. All questions are about the molecular orbital. Okay, so now I say the orbital mixing. They may not show in your contact book, but you need to know what's this. Okay, because I will have the question about this in the final exam. Okay? Okay, so here. So when you fill in the electron, there's no problem because for 2s there are 4 electrons. So 2 in the bonding orbital, 2 in the anti-bonding orbital, right? And then here, because in the beginning 2p is here, right? But it jumped up because orbital missing. Okay, so 2 electrons for boron is feeling like this. Okay, it's paramagnetic. Okay, it's paramagnetic. In the beginning, if there is no orbital missing, it's just like this. 2 electrons is filled into the sigma 2p. It's diamagnetic. But the truth is, because the orbital missing, so sigma 2p jump up. Okay? So that's why 2 electrons in the boron's 2p will fit in at pi 2p. So there are 2 ampere electrons. So this is paramagnetism. Okay? Okay? It's paramagnetism. Okay? 有听懂我在讲什么吗？ Okay, suppose the regular one is 2s2p, 2s star, sigma 2p, sigma 2p star. The pi bonding are between 2 sigma. Okay, but for boron, because sigma 2s is closer to sigma 2s star, so they have the interaction. This interaction is what we call orbital missing. Okay? It's what we call orbital missing. So that's why it's jump up like this. The sigma 2s move up. Okay? So the electron feed is not fit into the sigma 2p. Okay, it's fit into pi 2p. Okay, so there are 2 electrons, so there are 2 ampere electrons. So for boron B2, okay, diboron, okay, it's paramagnetism. Okay. If there is no orbital missing, suppose 2 electrons have to fill into the sigma 2p, right? Right? And it's a paired electron, so there is no magnetism. But actually, there is orbital missing happened. Okay? So the 2p jump up. So pi 2p is lower than sigma 2p. So when I fill in the electron, I won't fill into sigma 2p. Okay? I will fit into pi 2p first, because the energy level of pi 2p is lower. Okay? So it's what? There are 2 ampere electrons. So it's the paramagnetism. Okay? 第二，你有听懂吗？你要仔细看哈。原本 in the beginning, okay, suppose it's 2s sigma 2s sigma 2s star, and sigma 2p and 2 pi star and sigma 2p star, okay? But I say, because sigma 2s is closer to sigma 2p is closer to sigma 2s star. Okay, all of these are sigma. They have the same phase. Okay, so that's why there is interaction happened. They do overlap to each other. This kind of overlap we call orbital mix. Okay, missing. After orbital missing, the higher energy of orbital will jump up. the sigma 2p is higher than the pi 2p. And the sigma 2s star, the lower missing orbital, will decrease. Okay? So, it's not like this anymore. It's just like this, as I say. Sigma 2p jump up, right? Sigma 2s star decrease. Make this, longer space. Okay, the difference, make a bigger difference. Okay, so when you fill in the electron, for this one, you fill into the 2 electron. So now it's 2 ampere electron. And we already mentioned ampere electron, what do we call? It's a paramagnetic compound, right? There is the magnetic properties. But if there is no orbital missing, for example, like this, 2 electrons suppose fill into the sigma 2p. So it's plus half and minus half is cancelled, spin up and spin down. Okay, so this is what? Diamagnetic compound, because no ampere electron, right? So if you use a magnet, 弄一个磁铁去吸它，会不会吸动？不会啊。OK， 但是 but in actually for B2, there is orbital missing happened, so sigma 2s jump up here. So when you feed in the electron, you should fill into the pi 2p and pi 2p first. So there are 2 ampere electrons. It means B2 is a paramagnetic complex. OK? 这样有听懂吗 ？OK？ 有听懂吗？ 至少听懂吗 ？OK？ So I can teach you later. Okay, so here. So this is what we call orbital missing. So the periodical table for the second periodic table, atomic atoms in second periodic table, the second period. Okay, for example, B2, because there is a closer, the 2 sigma 2p is closer to sigma 2s star, so there is orbital missing. C2 has the same. Okay, so their orbital is like 2s 2p, no problem, right? But because orbital missing, the sigma 2p in the beginning it was here, okay? Because orbital missing, so it jump up here. Okay, so when you fill in the electrons, it's totally different. Okay, so for this case, for C2, there are 4 electrons, so you have to fill into pi 2p. Okay? Okay. Then how about N2? Same thing. They have the orbital missing, so it's like this. It's the pi 2p, sigma 2p. It's the 2s, sigma 2s star, sigma 2s, right? So for 2s, there are 4 electrons, so you can fill, fully filled, right? Then up here, 6 electrons, 1, 2, 3, 4, 5, 6. So for N2 is what? It's diamagnetic. Because there is no unpaired electron. Here is also diamagnetic. And this one, there are 2 unpaired electrons, right? So it's the paramagnetic. Okay, so until diapostate, because their sigma 2p and the sigma 2s star are far away, so there is no longer orbital missing. 这里没有 orbital missing. No, because the distance between sigma 2s star and sigma 2p are too far, so they won't overlap to each other. There is no interaction. So the orbital, p orbital is what? Just like a regular sigma 2p, pi 2p, pi 2p, pi 2p star, pi 2p star, and the sigma 2p star. Okay? So it's like this. So when we fill in the electron for dioxygen, okay, 2s, 2p, 4 electron filled. Okay? And here, 4 electron, 1, 2, 3, 4, 5, 6. And there's another one fill into the pi 2p star. Okay? So for dioxygen, is paramagnetic or diamagnetic? There are 2 unpaired electrons. So it's para or di? It's para or di? Louder? Para. Okay, good. Right? It's paramagnetic. Okay, as I mentioned, paramagnetic means this molecule with magnetic properties, right? 就是它有磁性。So it means you use a magnet to close to it. It will attracted by a magnet. 也就是它会被什么磁铁吸引。Okay? But for O2, if we use the Lewis structure, it's suppose what? It's a diamagnetic compound, right? For the Lewis structure. So let's see the real world. Okay. This is a magnet. Okay? And this is what? The liquid oxygen, 液态氧. So you can see the 液态氧被什么磁铁吸在中间. The liquid oxygen was, or are, or is, attracted between a magnet. Since it can be